Good afternoon, Mindsetters. Welcome to yet another exciting show of Mindset Learn. You tuned in this hour with myself, Deborah Precious, and your favorite sciences teacher, Tracy. How are you?
I'm well, thanks to Boko. And Mindsetters, I hope you're well as well, and that you've got your thinking caps on, and that you're really going to be interacting with us today.
Could you just briefly let them know what we're touching on today?
Absolutely. Mindsetters, we are solving motion problems. We're going to be tackling equations of motion, the 4 equations of motion. So there's lots and lots in store. And all these kind of things built together. So notice in the first show a couple of weeks ago, we started talking about, 3 weeks ago, we talked about an introduction to motion, and we talked about the definitions. Now, and then last week we discussed graphs of motion, and this week we're going to draw it all together and look at the equations of motion and solving lots of motion problems. So I hope you stay tuned and you get your calculator out and you pens and paper out and really get working with us.
Yeah, and speaking of calculators, don't forget that this beautiful Casio is up for grabs once again. All you have to do is answer the questions on our Curio page, and it's also revision, guys. It's not just about winning the Casio calculator. And then after answering the questions, you submit, and the people that get 100% of the answers correct stand a chance of winning this beautiful, amazing Casio calculator. And don't forget to get in contact with us on our Facebook page, which is facebook.com/LearnExtra, or on our Twitter handle, which is @LearnExtra with an X. And then I'll be here, everybody else will be here waiting for your questions, and we'll be just ready to answer anything that you have in store for us. Tracy?
Thanks so much, Taboko. So Mindset, as we said today, solving motion problems. Let's just run through what we will discuss. I said to you we will tackle those 4 equations of motion, and those will stand you in good stead. This year we introduce them, next year in grade 11 you use them lots, and in grade 12, so very important that you've got those 4 equations of motion. We will look at lots of calculations for velocity, acceleration, time, displacement, maybe it's speed, all those different things that we can calculate, and always we are solving problems. So I said to you, get those thinking caps on. We've got important things to discuss. Always, I give you a challenge question, and that challenge question is there for you to challenge you, to get you thinking, to make sure that you can tackle this on your own. Because the reality is that I won't be standing there in the exam room with you. You have got to be practicing the stuff so that when you see an unknown question, you can actually do it. So, I'm challenging you today with this question. A bus is traveling north, that's helpful, on a main road at 14 meters per second. The driver applies the brakes and comes to rest at a bus stop, covering a distance of 48 meters. It is stationary for 30 seconds while a passenger gets off the bus. The bus then accelerates to a constant velocity over 8.5 seconds. So we've got lots of time values, we've got distance values, number of things. While it's accelerating, it covers a distance of 67.92 meters. Take north as positive. So they've told you the direction that the bus is traveling. We must take that direction as positive. The question asks us 2 simple questions. Determine the acceleration of the bus during each of the stages of motion. So notice there is 3 different parts to this question, to this motion. The bus initially is traveling, and then it slows down to come to stop at the bus stop. The second stage would be while it's stationary at the bus stop, and then it's accelerating again. So that's the 3 stages. And they're asking us to determine the acceleration of the bus during each stage. And then they say to us, draw an acceleration versus time graph for the motion of the bus. So using the information that you just found in the first part, draw an acceleration versus time graph. So that's the challenge question for you. In terms of a graph, I want you to draw it, and what you can do is, in terms of loading it, you can certainly load that picture onto the page. So make sure that you're interacting with us and you are trying these questions for yourselves. Let's move on to the summary. Now, I said to you today that we want to draw together and revise some of the concepts that I introduced 2 weeks ago and last week as well. When we speak about motion, we have a few useful definitions. Firstly, I want to tackle average velocity. This equation is the displacement divided by the time taken. So how far an object has been displaced from its starting point to its end point, change in position, divided by change in time. But I want you to notice that if you were to use this equation to work out how far an object has moved, you can only use this equation if the velocity is a constant velocity. The reason for this is because this velocity is an average velocity. So it can only be used to define the displacement if the velocity is constant. And I make that point because I've seen a number of times students go and use this equation when actually an object is speeding up, so going faster and faster, or slowing down. And then if something is going faster, at the end it will be going at a higher speed, and so will be covering a greater distance per unit time. So do make sure that you are aware that this equation, that v is average velocity, so it can only be used to define, say, the displacement if you've got a constant velocity. The next important equation that I want to mention to you is acceleration. Acceleration is the change in velocity of a change in time, and that little delta sign, that little triangle, is referring to change in. Now when I say a change in, it's always a final minus an initial. So how something has changed. Where is it now versus where it was? How fast is it going now as opposed to what it was? So it's a final minus initial. And so I've written here VF minus VI. The final minus the initial. And initial means at the start over change in time. Here, the velocity is changing. So notice in the first one we said velocity is constant. Here, velocity is changing. So you will have final and initial velocity. And that equation can be a very, very useful equation. And always you need to be able to rearrange an equation. So maybe I wanted to ask you to find what the final velocity was. Can you take that equation and shuffle it around, rearrange it? And actually, if you can change the subject of the formula to rearrange it, and I'm going to ask us to rearrange this equation into solve for v. So I'm going to give myself some space at the bottom of this page, and I'm going to write the original. Acceleration is v final minus v initial divided by time. Can we rearrange that to solve for v final? That's what I want just by itself on the one side of the equal sign. Well, when you're doing this, it's actually just a little bit of maths. And you need to make sure that you brush up on your maths so you can tackle some science here. Because all we're doing with the science is rearranging. So notice, that's what I want by itself. I'm going to start with the time, take that to the other side. So I've now got acceleration multiplied by time. Why? The time was dividing on the right-hand side, so when I take it across, do the opposite operation, and it's now multiplying, is equal to v final minus v initial. Okay, I said I wanted just v final by itself, so the v initial must move to the other side. And this v initial, I want to take across. It was minusing that side, so when it goes across, it's going to be plus. So a times t plus vi will give me v final. And I'm just going to reshuffle this. I want to switch it around. V final is equal to v initial plus a times t. Do you notice that there I've just swapped them around? It doesn't matter if you said 2 plus 3 or 3 plus 2. If you're adding these things together, it doesn't matter which order we write them. The reason I'm doing that is because I want you to recognize this equation is actually just a rearranging of that initial equation. I've just shuffled the things around, making v final the subject of the formula. And that is what they've done in developing the 4 equations of motion. You will notice this equation that I've boxed in yellow is actually quite a familiar equation. It is the first equation of motion. And it is simply the definition of acceleration that has been rearranged. So I want to take you back to this top here, and notice we've actually got that equation of motion, and all the equations of motion are actually simply rearranged to solve for different things. And what you'll notice is that each of them have something that is not in the equation. So notice in this first one, there is no information about displacement, which is valuable because if maybe I don't have displacement, but I'm looking for the time, then I can't use the second equation because it's got displacement, because that's an unknown. And then I would have two unknowns in the equation, which mathematically you can't solve if you've got two unknowns. Next one's also got displacement, and the last one's also got displacement. So I would have to then choose that first equation of motion. Similarly, for each of them, you'll notice this one does not have any information about the acceleration. The third one doesn't have final velocity, and the fourth one doesn't have time. And each of those are simply mathematical constructs to make sure that you can solve with just one unknown in the equation. So those 4 equations of motion, they're on your data sheet, use them, but make sure that you can, you don't need to know how to derive them, but it can be valuable just to get your mind around where they come up with them. So I want to talk you through some hints and tips as you look at answering motion questions. Firstly, I recommend, this is not required, but I recommend that you sketch the scenario. So that question of the bus that was slowing down and then stationary and then accelerating, it helps you to picture the scenario. So very often I sketch the scenario. And then I want to suggest that you list all the known information. So maybe across the top of the page, or maybe if it's 3 different stages like in that bus scenario, you've got to list the information under 3 columns. List the known information because that's going to help you to know what equation to use. Convert to SI units, and that's another valuable concept in terms of when you list the information, because if you write it down and you suddenly see it's kilometers per hour, alarm bells should be saying, hold on, make sure that you convert. And then choose the appropriate equation. So we've got an equation we can choose, then it's simply to substitute, to solve, and always give your answer with units and direction. Remember, many of these quantities are vector quantities. What do I mean by a vector? It means it has magnitude, size, and direction. So for acceleration, you can't just simply write so many meters per second squared. You have to write so many meters per second north or south or east or west or forward or in the opposite direction to motion, whichever would be appropriate, but you have to give a direction because it is by definition a vector quantity. And then check you've answered the question. Very often the question will ask you a specific piece of information, like, I know we've got one coming up, has this person exceeded the speed limit? And you've found an answer, but you must make sure that you actually go and answer the exact question. So those 7 points, I think, will help you to tackle any motion question that you will ever get. So sketch the scenario, list the known information, because those 2 points will help to make sure that you've interpreted the question correctly. Convert to SI units, find an equation, substitute and solve, and give your answer with units and direction, and then go back and check you've answered it correctly. Mindset is, that's all for our summary for now. What I want you to do is make sure that you go now during this ad break and try that challenge question. Tebogo, over to you.
Mindsetters, I'll be watching on the page to see who gets to answer the challenge questions correctly. And I have already posted the link to the notes, so make sure you download them or view them so that you can follow through the lesson with us. I'll see you guys after the break. Welcome back, grade 10s. Now I'm sure you're all aware of the awesome competitions that we have running. If not, listen up. You can stand yourself a chance of winning an amazing Sony Xperia L and airtime vouchers brought to you by Vodacom. All you have to do to enter the competition is you do so via our Curio page. Now, a link is provided on our Facebook page together with the code, which is LEARN. So you go on Curio, your code is LEARN, and then you select your favorite teacher. You vote for that favorite teacher, and once you've done that, you move on to our Facebook page, and then you like the graphic of the teacher that you have chosen through the links that we provided on our Facebook page. It's that easy, guys. If you get a little bit confused, do visit our Facebook page. It explains everything clearly. And then the people with the most likes, or you can share it and get as many friends as possible to like your photo, which is the teacher that you chose. And then the people with the most likes, Tracy, for example, the people with the most likes, get this, get to enter into, they stand themselves a chance of winning an amazing Sony Xperia L together with vouchers, airtime vouchers, courtesy from Vodacom. It's that easy, guys. And don't forget to follow the lesson on our notes, as well as ask your questions on our Facebook page, which is facebook.com/LearnExtra or LearnExtraLive, or on our Twitter handle, which is @LearnExtra with an X. Tracy, over to you.
Thanks, Tebogo. So Mindset is we do want you to interact with us and be part of our community, because Mindset is this is how you're going to learn from one another. Post your questions, answer questions, and get part of our Mindset community. It's really awesome. So I said to you we want to go through some questions, and this challenge question, this question I've got in terms of improving your skills, comes from a past exam paper exemplar. So we've got there, a delivery van is traveling at a constant speed. All these different points I would suggest you highlight or underline. At a constant speed of 15 meters per second in a 60 kilometer hour speed zone. Now, for those of you mindset is, you might be getting to the age 17 years old, and you can start going for your learner's license and your driver's license as you get older. So be part of our community. As I just mentioned to you, just after the grade 11 show or the grade 12 show, there's going to be a snippet on alley docking, I think, and starting to help mindsetters learn to drive. So very helpful as you think about driving cars, and this is a delivery van in a 60 kilometer per hour zone, which is the normal speed limit in a city centre. When the driver sees people crossing at a pedestrian crossing, so we've got a pedestrian crossing and that is 50 meters ahead of him, and so of course he must stop for the pedestrian crossing. The driver takes exactly 1 second to react. And we spoke about reaction times a bit, because the reality is it will take a bit of time for the message to be sent from the image on his retina, in his eyes, to be sent to his brain, to his legs, to go foot off the accelerator, foot onto the brake. And there will be that reaction time. It's telling us his reaction is 1 second. Before he applies the brakes, as hard as he can, it takes a further 3 seconds for the van to come to a stop. And they've given us a picture. Now, they didn't have to give us a picture, but remember I said to you, it's one of the most helpful things in terms of interpreting a question is if you draw or sketch the scenario. So there we've got the truck. It is going at 15 meters per second. Reaction time of 1 second, and I want to add into that, okay, that's his reaction time, and then it takes a further 3 seconds to come to a stop. We don't know whether he stops at the pedestrian crossing, beyond the pedestrian crossing if he doesn't get to stop in time, or before, but I'm writing there 3 seconds with a little arrow. The whole road that he's driving on has a 60 kilometers per hour speed limit, and they've told us that the distance from the truck to the pedestrian crossing is initially 50 meters. Okay, so did the driver of the van exceed the speed limit? And so was he going more than 60 kilometers per hour? Show all your calculations. Well, we know he was going 15 meters per second, and so 15 meters per second, we want to convert to kilometers per hour. Now, you want to be able to compare that to what we know the speed limit of 60 kilometers per hour is. So how do we convert? Well, I want us to, let's go down here and note that when you go from kilometers per hour to meters per second, you have to say, well, kilo is 1,000 meters, and an hour is 60 minutes, and each minute has 60 seconds in it. So 60 times 60, which is 1,000 divided by 3,600. And that means you need to multiply by 1,000 divided by 3,600. Or if you're going the opposite way, so if we were trying to go from meters per second to kilometers per hour, we're going to have to do the opposite. We will have to say, okay, so instead of that, we would need to, instead of multiplying by, that looks like it's a cross there, instead of multiplying by 1,000 over 3,600, I want to multiply by 3,600 divided by 1,000 would take me from meters per second to kilometers per hour. Notice I've done the inverse, okay? But it's helpful to know where you get those numbers from. It's because kilometers would be 1,000 and the hour would be 60 times 60. So working on that, we've got our calculator out, and it would be 15 multiplied by 3,000, 15 multiplied by 3,600 divided by 1,000, and it's giving us 54. So he is actually traveling at 54 kilometers per hour. So well done, he was not speeding. And that is, let's go back up here, is 54 kilometers per hour. So did the driver exceed the speed limit? No. He was not speeding. This is one of those points where I took you back in the summary to say, just check that you've actually answered the question, because many students will get to the point of saying 54 kilometers per hour, but then will lose marks because they actually haven't answered the question, and the question asked about speeding. The next one. Calculate the distance that the delivery van travels during the 1 second reaction time. Now, notice he's taking that 1 second to react. So what speed is the van traveling at while he's still going, while he is reacting? He hasn't yet put his foot on the brake. It's the time it's taking for him to react and respond. So he is still going at 15 meters per second. And so I want to say, let's just write point B here. He was going at 15 meters per second, and this is my initial velocity, and it's also my final velocity. It is a constant velocity because he is not yet braking. He is still going at that velocity. So I can choose to use, and the time here is 1 second, and we are looking for the change in position. Notice I'm writing a list. Then I can come along and say, okay, I can choose an equation. And this equation will be valuable because I have a constant average velocity, and that is the 15. So let's rearrange the equation. It's going to be V multiplied by T is going to equal to delta X. It was dividing, I take it to the other side, it becomes a multiplying. So delta X is equal to 15 multiplied by 1, which we know is going to be 15 meters. Notice you would identify that he has already traveled 50 meters before he stops braking. And that's very important because now he's only got a much shorter distance to stop the van. Next question. Calculate the distance. We had there, it was 15 meters. Will the van stop before the pedestrian crossing? Show all calculations. Now I want to go back to this picture and help just write in a bit of information. So we said, okay, he's reacting. He's already taken up 15 meters. He's got, what would it be, 35 meters still to go. And but he's only taking 3 seconds more to stop this van. We need to list our information. And I want to go down, give ourselves lots of space. We are going to say, okay, V final, V initial, acceleration, time, delta x. Now, as you write this list, you can fill in as much information as you know. What must the final velocity be? This is important to think about. We're saying he must stop the van. So the final velocity, they haven't given it to you, but you know it must be naught because he must come to rest. The initial velocity, he was initially going at 15 meters per second, and after he reacts by putting the foot on the brake, that is the 15 meters that he's starting at. Acceleration. Do we know anything about the acceleration? No, we don't. They don't tell us what the acceleration is. They just say he's braking as hard as he can. So we don't have any information, and I can't write anything in there. The time is 3 seconds. The delta x, that is what I'm trying to find. Now, many people might say, oh, can I put the 50 in there, 50 meters? No, because that is what we're comparing to. That is, will he stop in time if we've got that distance? But we've got to use the other pieces of information to find out if he will stop in time. So now I go along and say, okay, if that is my information, what equation can I choose? I don't want to choose an equation with acceleration in it because I don't have any information about acceleration. So I'm going to need to say, okay, let's choose an equation, and I'm going to choose delta x is equal to v initial plus v final divided by 2 times by time. And that equation, you'll notice, does not have acceleration in it because I don't have any information on acceleration. The initial velocity was 15. The final velocity must be 0 because he must stop, divided by 2 times by 3. So let's jump across to our calculator, clear that. 15, notice I'm working in SI units, plus 0, which is just 15, 15 divided by 2, and I want to say that's going to be 7.5 times by 3, and it's giving me an answer of 22.5. So I come down here and write in that is 22.5 meters. Now, let's think this through. As the van was going along, he first covered 15 meters. Then he's covered another 22.5 meters. This was in the 1 second reaction time. That was in the 3 seconds that he's braking. So how far has he gone? Well, we've got to add those together. So 15 plus the 22.5. And I'm going to just simply add 15 to that. Is giving me 37.5. So, has he stopped in time? Yes, he has. He has covered a total of 37.5 meters, and that is way beyond the 50-meter pedestrian crossing. So he has stopped with enough distance before that pedestrian crossing, which is great, great news. So, going across, we had the picture. Will the van stop before the pedestrian crossing? Yes, he will. He covers a distance of the 37.5 meters, which is before the 50 meter. And notice we didn't use that 50 meter in our in answering the question in terms of substituting that value, but we used that in our comparison at the end. It is our answer is within that, and so we can compare that value. Will the stopping distance of the van increase or decrease when the road is wet? Well, we need to consider what happens when a road is wet and slippery. Sorry, it looks like my pen went slippery there. When object is wet and slippery, there's much less friction, which means that the backward force on the road is going to be much less. So on the tires will be less, and the acceleration will be less, or the deceleration will be less. So in answering this question, we need to think the time that it will take will be much higher. So I need to write in here, time will be higher. That's my little shorthand for higher. And so to get the same change in velocity, to get from what he was initially going at to rest, will take a much longer time. So let's jot that down. Will take a longer time for the same change in velocity. Change in velocity. Because the road is less slippery, more slippery, there will be less grip on the tires, and so the force will be much less, and that will take a much longer time to get that same stopping. So mindset is that's our one question. We want to come back and tackle the challenge question, so make sure that you've gone and answered it during this ad break. Tebogo, over to you.
I see a couple of you are already liking the challenge question. Mindset is, I'm assuming that means you're on it. So we'll see you guys after the break. Hopefully you're correct. Welcome back, grade 10s. Do not forget about our Get Connected competition. Don't forget there's only 2 Sony Xperias up for grabs now, the Sony Xperia L as well as Vodacom Airtime. Now, come on guys, at least try and make sure you count it among the winners. Don't forget about the competition. Get as many likes as possible. Don't forget to get in contact with us on our Facebook page, facebook.com/LearnExtra, as well as our Twitter handle, which is @LearnExtra with an X. Tracy, over to you.
Thanks so much, Tebogo. So mindset is we're going through that challenge question. We're going to tackle it now. And again, it's coming from past papers. So always valuable to do as many type of questions as possible. This is an exemplar question. A bus is traveling north on a main road at 14 meters per second. So I'm going to circle that. The driver applies the brakes and comes to rest, another point of information, at a bus stop, covering a distance of 48 meters. It is stationary for 30 seconds while the passenger gets off the bus. The bus then accelerates. So first it was braking, then it was stationary, then it was accelerating to a constant velocity over 8.5 seconds, covering a distance of 67.92 meters while it's accelerating. They're telling us to take north as positive. Determine the acceleration of the bus during each of the stages of motion. Now, I suggested to you that you start by always sketching a scenario. Now, my sketches, I'm not an artist, but my sketches are always very simple. That is the bus. And then I'm going to have stage 1, stage 2, and stage 3. Now, stage 1, write down information as best we can. Here it was decelerating. Stage 2, it was stationary, not moving. Stage 3, it is accelerating again. So I would like to even predict what is the acceleration going to be. During this first stage, it must be negative. Why? Because it's decelerating. So acceleration will be negative. Here, is it moving? No. So if it's not moving, it's not going to be accelerating. And the last one here, acceleration will be positive. Now, those can just help you to think through what, when you get your answer, what you're going to do with it and if your answer is correct or not. Then I suggested, so sketch the scenario. Then I suggested that you write or list all the information that you know. So I want to start by writing that information, and V initial over here is going to be, what was it? I think it was going at 14 meters per second. 14 meters per second. When it gets to the second stage, this would be the final velocity, and it is at rest. What else do we know? Do we know anything about time here? We're looking for the acceleration. Do we know delta x? Yes, we do. I think they said it was 48 meters. So I'm writing down all that information. Now I can come along and say, okay, which equation will I use? I want to choose an equation that has got everything except time in it. And I want to recommend to you that you, maybe even as you write your list of your 4 equations of motion, that you write in there which one it doesn't have. So I can know immediately the equation I want to use is one that does not have time. And the equation I'm going to use is the 4th one. V final squared plus is equal to V initial squared plus 2a delta x. And then we can substitute and solve. Always, mindset is write down the original equation first. You have it on the data sheet and it's a matter of copying down the equation. Take the original equation. Many of you might say, oh, but I'm confident to move the solve for the subject of the formula and then shift things around, but don't. Write the original equation first, because in a test or an exam scenario, you might well be feeling under pressure, and then if you write the wrong equation, you're not going to get any marks. But start with the original equation, as I've done here, and then you can substitute. Now, what we're actually looking for there is acceleration, and you could rearrange it, but once again, you need to substitute, and you'll get marks for your substitution. And if you substitute correctly, you get all those marks. But if you rearrange it incorrectly, then you will lose all those marks. So first, really substitute is a good plan. So what is the final velocity? It must be 0, and that is squared, equal to, it was the initial velocity, which was 14 squared, plus 2 times a multiplied by 48. Notice I've substituted with little brackets indicating those values, and then I can rearrange it. Now, you could square them first, and maybe that's a good idea, but to show you the rearranging while you've got all those numbers, it's going to be 0 squared minus 14 squared, let's just keep the brackets, divided by, okay, the 2 times the 48, 2 times by 48 is equal to A. Many of you might feel more comfortable solving first, and that's perfectly acceptable. So doing the squares and that kind of thing first, perfectly fine. Let's grab our calculator, and I'm going to do it here and say, okay, well, it's going to be 0 squared is 0, 14 squared is 196. So just on the side, I'm going to go here and say, okay, if you hadn't, I'm going to just take this line out, sorry. Let's just take this line out and solve first. So that's 0 is equal to 196 plus 2 times 48 is going to be 2 times 48 equals 96. So over here, it's going to be 96A. Now that might look a lot more simple to solve, and it is, because you've already done the square and you've already multiplied by 2 and all of that. So now we can rearrange. And so the 96 comes to the other side, and notice it's going to be 0 minus 96, 196, sorry, and then divided by 96 is equal to A. And that does look a lot more manageable. Now, going to my calculator, and it's negative 196 divided by 96 equals, and we get a big long number. But notice, key point to note, it's got that negative 2. And I've predicted at the start that my answer here, would be a negative. And it is. It's coming out as a negative. Why? Because that bus was decelerating. It was coming to rest. And so I'm checking my answer there, negative 208. A is equal to negative 2.04, I think it was. Let's give ourselves some space. Meters per second squared. Now you will never leave your answer with that negative. First, you will write the number with the units, and then you must interpret what that negative means. That negative means that it was decelerating. So if the bus was going north, this acceleration is to the south. And that is important. Remember, I said to you, always make sure you're giving your answer with units and direction. The next one was stage 2 of the motion. We already had worked it out. Acceleration is 0 meters per second squared. And then the third one, we had a whole another set of information. So let me go and write it up, and I'm going to change pen color so you can very clearly see. We're doing stage 3, and here, then the bus accelerates to a constant velocity. We have a different time and a different displacement. So let's write those down. Here I've got V final is equal to V initial is equal to, acceleration is equal to, time is equal to 8.5 seconds, and delta x is equal to 67.92 meters. I think that was it. 67.92 meters. Okay. Do I have anything about the final velocity? No, I don't. But it was stationary at the start of stage 3. So we have got 0 meters per second here. Do I have enough information? Yes, I do. I can substitute with those ones. So let's write an equation. We can have here delta x is equal to VI times t plus a half AT squared. So substituting in 67.92 is equal to VI was 0 times by 8.5 plus a half A 8.5 squared. Once again, substitute, because you will be able to get marks for all those substitutions. this whole term is going to come to naught because anything multiplied by 0, you know, would be 0. And then let's solve for this. So 8.5 squared. 8.5 squared is equal to that, and I'm saying multiplied by 0.5, and so we get 36.125 plus 36.125 times by A. And now we can take that value to the other side. So 67.92 divided by the 36.125 is going to give me the acceleration. And we can go across to our calculator. 67.92 divided by 36.125 equals 1.88. And once again, my prediction was that it would be a positive value, and it's come out as a positive value. Perfect. So we have 3 very important pieces of information. Each of those accelerations, and that's going to take me to my acceleration versus time graph. Now, I haven't gone and worked out the time values because you could go and do those so that you could actually sketch this nicely on your graph. I've worked them out previously. Time is in seconds. But I want to just sketch what this graph is going to be for you first. It was initially some value down here of negative 2.04. And then it was 0. And then it was roughly there, 1.88. So notice we've got 3 values and we're going to plot them. I want a dotted line. Let's try that again. It is initially negative 2.04, and then for 30 seconds it is stationary, and then it is, sorry, that's a little high, 1.88. Now you would be able to go and work out what the time is, and this time, and I certainly haven't drawn it to scale, because this time I know works out to 6.86 seconds, and then this time must be, it was 30 seconds in duration. There was 30 seconds, so it gets to 36.86, I think, and then we had another time of 8.5 seconds. So certainly you would need to draw that more to scale, but I want to just make sure that you have the sketch of what it would be. It is below the line initially, and then horizontal on 0, and then horizontal as a positive. And each of those is valuable because what it's saying to you is it was decelerating, and then it didn't have any acceleration, and then it was accelerating. So mindset is, I hope that's really, really helped you today, and that as you work through these challenge questions, as you solve equations of motion type problems, that you keep in mind all of those steps and write down the original equation first and then substitute and solve. So I hope that's really helped you. From me, Tracy, keep well, God bless, keep thinking and challenging and encouraging one another. God bless, stay well, and I'll see you next time. Katlego. Thanks to Tebogo.
Mindsetters, I trust that you've had a valuable learning experience, and don't forget to keep asking us questions. Just because the show is over doesn't mean we're not available anymore. A big shout out to some of our mindsetters, Mpho, Lungile, Tato, Lerato, Makaye. You guys have been very active on our Facebook page. Thank you so much. It's good to see your activities going on, and stay tuned for some learning how to drive tips and advice on the insert that's coming just after the show. Today's focus is on alley docking, so stay tuned. I'll see you guys in a few minutes, I think. Okay, bye.